What is a monomial? What do you think monomial is? Is there any letters in that word that might give you a clue? What does mono mean? Very good. One term, one number. So for example, y equals 3x. That's a monomial. Y equals 2. That's a monomial. Only has one term. What does a binomial function look like? Two terms. Y equals mx plus b. What kind of equation is that? It's a binomial, meaning it has two terms. So what would this one look like? What is that kind of function? Very good. It's linear. Trinomial means three terms. What kind of equation is that? Has three terms. Terms. Have we seen this before? Chapter 3. Yes, the graph is a U. What do we call that in mathematics? It is a function, yes. Because we're going to discuss how do you know it's a function? A function has to be one-to-one. How do we know it's one-to-one? Well, first off, it has to pass the vertical line test. It's a function. And we'll also talk about it. If it's one-to-one, it also has to have an inverse. Does it have an inverse? So we'll talk about that. We'll talk about it. We'll review that later on. So you're right. What is the name of this U-shaped function? The name of it starts with a P. Yeah, I know what you want to say. You want to say polynomial, but that's what we're looking at. We're looking at all these. All these are polynomials. It's a parabola. How do you know what the shape of the graph is going to look like? What in this equation, any of these, what do these tell you what it's going to look like? Which X? First one, yes. Well, more so, the whole first part of it. These are called, since it has an X squared, it's called a quadratic equation. Quadrinomial has four terms. So what is this one going to look like? No, no. Again, we look at this graph will look like this. It's called a cubic because the highest power is 3. What's the name of this highest power part? We talked about that a couple of chapters ago. Starts with a D. Degree, very good. It's the degree. The degree of the equation tells us what the graph's going to look like, how many x-intercepts we can have, what the end behavior of the graph is going to look like, which direction the graph goes. So everything else we call polynomials. Poly means many. Many terms. So a polynomial looks like this. Polynomial looks like this. N number of terms. Basically, what the degree tells us is, if you look at this, the number of x's is one less than the number of a's, because there's no x on this one. The degree is whatever n is, the largest exponent. The term that has the degree is called the leading term. The term that has the highest exponent is the whole leading term. Be very careful, because in your homework, you may have equations that look like this. So what's the degree of that polynomial? Is that the biggest exponent? 5. It may be mixed up like this. So the first thing you have to do is make sure that you put it in terms that are decreasing exponents. This is not wrong, it's just not conventional. This is conventional. You always put the highest exponent first going down. So yeah, so we know that it's degree 5. So in the leading term, we have the degree, that's n. What does the degree tell us? What does the degree tell us? Yeah. The shape of the graph. What else does it tell us? Very good. I guess that defines what's called the end behavior. We'll talk about that in a second. Because it's either going to be odd or even. If it's odd, then we know both ends point different directions. If it's even, both ends point the same direction. Very good. I got to thought about that. It tells us one more thing. It tells us the maximum number of solutions possible. If you think about it, okay, now we've defined this before. What's a solution? What's another name for solution? Specifically, which point? Very good. It's the x-intercept. So whenever we say solutions, we're talking about the x-intercepts. Or we could talk about what are called zeros. They're the same thing. It's just they're written differently. The x-intercept is a point. It's a location. The 0 is a value x. It's a value of x that makes the equation equal to 0. So you see, all this stuff is built upon just by looking at it. And all this is simply from the largest exponent. What is this part called? The a sub n, the number in front of the x, the coefficient. Leading number. It is the leading number. So a sub n is called the leading coefficient. It is. It's the number in front of x. But to be more mathematical, we say coefficient. Because everything else would sound too boring. So here we have a, and there we have n. Remember, our leading term looks like this. If a is greater than, if it's positive, or if a is negative. If n is odd versus even. Oop. Is everybody familiar when I talk about end behavior? What does end behavior mean? The ends of the graph. Because any graph you have, it goes two directions. What happens when it goes to negative infinity? What happens when it goes to positive infinity? Every graph has that. So this is what this chart tells us. What's going to happen as the graph goes to negative infinity, or when x goes to negative infinity or x goes to positive infinity. If a is positive and n is odd, the end behavior looks like this. They go opposite directions, increasing, because as x goes to positive infinity, it goes up to the right. Because it's odd, it has to go opposite directions. If a is positive and n is even, the graph looks like this. Of course, we don't know what happens in between those two. We just know what happens at the end. If a is negative and n is odd, then it goes opposite direction. As it's a decreasing function, because as x goes to positive infinity, it goes down. And if the degree is even and a is negative, then it goes down. This is going to help us graph polynomials. How? Every polynomial can be broken down to the x-intercepts. We can find the x-intercepts. Okay, this a and this a not the same. For example, If our polynomial was x squared plus 5x plus 6, how many intercepts are we going to have there? Well, what's our degree? The degree is 2. So what that means that we have a maximum of 2 possible x-intercepts. We can have 2 x-intercepts. It could just touch once, or it doesn't touch at all. So we know we're supposed to have at most 2 x-intercepts. So let's factor these. Remember how to factor these? You first, because whenever you solve for these things, you always solve for the middle variable. That's why the x goes there. What signs go in there? Right, negative. It's either positive, yes. So in other words, when we look at this, to figure out the signs, look at the second sign. If the second sign is positive, then the signs are the same. So the second signs are positive, that means the signs are the same. So what are they, positive or negative? Look at the first sign. If the second signs are positive, then the signs are the same. They are the first sign. If it was x squared minus 5x plus 6, then it would be minus minus. But since they're both the same, they're both positive, we know it's going to be plus plus. If the second sign is negative, then the signs are opposite. One's positive, one's negative. If the second sign is negative, then the signs are opposite. What does that matter? Well, how do you know which is which? Well, the bigger number gets the first sign. So in our example here, we have x squared plus 5x plus 6. It's quadratic, so we know there's 2 possible solutions. We solve for the middle letter, x. Second signs are plus, so they're both the same signs. They're both positive. So we have to figure out what numbers go in there. Remember, a polynomial, in this case quadratic, looks like this. To figure out what numbers make up this, first take the leading number and the last number. Forget the signs, just the numbers. Multiply them together, A times C. So in our example up here, what's the A? What value is A? 1. 1 times 6. is 6. So next what we're going to do is figure out what two numbers multiply to give you A times whatever that value is, A times C, that when you add them, you get the B value in the middle. Why is it add? Because this second sign is add. If it was a minus, that would be a minus. So we got to figure out what times what equals 6, that when I add them, I get 5. Yeah. And since they're both positive, 2 times 3 or 3 times 2, doesn't matter which ones. So that's the factor of that polynomial. What are my zeros? -2, -3. Because remember, when you're solving for these things, because we're looking for the x-intercepts, set the equation equal to 0. So we're setting both of these equal to 0. And since it's inside the parentheses, always going to be the opposites. So we know in this equation, at -3 and -2 are my x-intercepts. Those are my solutions. What do we know about the graph? It's quadratic. That means we have two solutions. Check. All right, look at the end behavior. Is the end behavior going opposite or the same direction? So to determine end behavior, you need to know what A equals, and you have to know what N equals. So what is A in our example? In this example, what's A? We only look at the leading term. Yeah. A is 1, which is positive. What is N? Which is even. Remember our chart we had up on top? If A is positive and N is even, that means both ends point the same direction. They both point up. That's what this chart tells us. So since these are the only intercepts we have, we know that the graph will go up from those endpoints. And the rest of the graph has to go below there. So let's go back and review the factoring part of all of this, just using quadratic equations. There are 4 basic properties here. Let's go backwards first. I'm going to do x plus 2, x plus 3, x plus 2, x minus 3, x minus 2, x plus 3, x minus 2, x minus 3. We're only dealing with quadratic equations. How do we know this is going to give us a quadratic equation? What these represent, these are factors. When I took a polynomial, I spread it apart, I get two possible answers. There are only 2 answers possible. Therefore, it's quadratic. If I had 3 of them, that means I have 3 possible solutions, then it's cubic, and so on and so forth. So that's what I said earlier, is the word solution is the same thing as intercepts, well, the x-intercepts. The zeros and we can talk about number of factors. So the number of factors tells you how many solutions you can have. Since we have two factors, then we have two solutions. All this stuff, I know it's a lot of words going in your head, but they all mean the same thing. That's what we have to be very, very careful about. So let's go ahead and multiply each of these together. So x times x gives us x squared. X times 3 gives us positive 3x. Positive times positive is a positive 2x. And then positive 2, positive 3 is positive 6. Combine like terms, we have x squared plus 5x plus 6. Bless you. So do the same with these last three. I'll pause it. All right. The next one. X times x is x squared. Positive times negative is a negative. X times 3 is 3x. Positive, positive is a positive. 2 times x is 2x. Positive times negative is negative. 2 times 3 is 6. Combine like terms. Negative, this 3 is bigger than 2, so the answer is negative. 3 minus 2 is 1. It's that. X times x is x squared. Positive, positive is a positive. 3x. Negative times positive is a negative 2x. Negative 6. Combine like terms. 3 is bigger than 2 and is positive. 3 minus 2 is 1. So we have x squared, negative 3x, negative 2x. Negative and negative is a positive. 2 times 3 is 6. So it's x squared minus 5x plus 6. That's called distributivity. That's if I give you the intercepts. If I give you the solutions, you can tell me the polynomials they came from. Think about this. Where did x plus 2 come from? Well, this is saying if x equals negative 2, I move the negative 2 over, I get x plus 2. If x equals negative 3, I move the 3 over, I get x plus 2. So these are the solutions. I put them in the equations they came from, and that's the equation they came from, the polynomial they came from. Because what we're doing now is we're going to start off with these, and we're going to end up with those. That's what the objective is with factoring. This is distributivity. This is factoring. So let's look at the first one. We have x squared plus 5x plus 6. Let's factor that one. So what letter goes first? Yeah, because we're always, so it's x and x. Second, what signs go in there? Right, because the second sign's a plus, they're both the same, so we go, they're both plus. What times what is 6? When you add them, you get 5? 2 and 3. So that's the factored form. Once you get that far, set them equal to 0, and you can find the x-intercepts. Those are the zeros. Why are they called zeros? Y will be, yes. If I make X is -2 and I plug it in there. So if I have -2 squared plus 5 times -2 plus 6. If I take my this value, plug in the equation. So -2 squared is +4. Positive times negative is negative. 5 times 2 is 10. 4 minus 10 is -6. So these are called zeros because if I plug them back into my equation, they equal 0. So that's why they're called zeros. These are my x-intercepts because at that point, that's when the graph equals 0. That's where the y equals 0. Now the next one, we have x squared minus x minus 6. What letters go first? X and X. What signs? Right. If the second sign's a minus, they have to be opposites. One of them has to be positive, because think about it. +2 times +3 equals +6. Positive times negative equals negative. But we have a problem. What numbers go there? Again, A is 1, so 1 times 6. We have to figure out what times what equals 6. That when we subtract them, it equals 1, the B value. 3 times 2 is 6. 3 minus 2 is 1. Because the B value is 1. That's what we're looking for. Here. What times what gives me the A times C? That whatever this sign is, if I add them, equals B. And if this second sign was a minus, then I have this number minus this number equals B. So the second sign is pretty important. It tells us what kind of signs we're going to be using. So we know that 3 times 2 is 6, 3 minus 2. So where does the 3 go? That sounds like a guess. You're right. It is the last one. Whatever this first sign is, the bigger number gets that sign. So since 3 is bigger than 2, 3 gets that negative sign because the first sign's negative. And that was that.
I said that because the last one, the 2 was the first one, and the last one felt like
Got lucky there, but it worked. But no, but that's the reason why. If you have if the second sign's a minus, the signs are opposite. The bigger number gets the first sign. That's basically the bottom line, what it says. X squared plus X minus 6. So they're both X's. The signs are opposite. Why? Well, no, but look at the second sign. If the second sign is negative, that means they're opposite signs. The bigger number is going to be a positive. The bigger number of what? Well, what times what equals 6? When we subtract them, we get 1. The B value. 3 times 2 3 minus 2. So in this case, since the first sign is positive, the bigger number gets the positive. Look at factoring this one. Since we're solving for x, that's good. What signs go in there?
Positive and negative.
Nope. Look at the second sign. If the second sign is a positive, then it says, no, yeah, if the second sign is positive, then the signs are the same. It's whatever the first sign is. If the second signs are positive, they're both the same. They're both, in this case, they'll both be negative.
So, both of them are negative.
If they're both negative, like this one, the second sign tells us that means there's going to be opposites. The first sign tells us the bigger number gets that sign. If the second sign's a plus, they're both the same. It's whatever the first sign is. So now we got to figure out what times what equals 6. When we add them, we get 5. 3 and 2. And since they're both the same sign, it doesn't matter where the numbers go. I can have x minus 3, x minus 2, or x minus 2, x minus 3. Doesn't matter which way they go. So far, so good? Here's the worst part. Only works for quadratic equations. Because we have a whole new set of rules when we get larger equations or polynomials. Factor that one out. When I do that. So yeah, so we did here, let me recap what we just did here. So what I'm looking for here is figure out what two numbers multiply to give you 10. Then when you subtract them, you get 3. 5 times 2 is 10, 5 minus 2 is 3. Now the signs are taken care of. These are the factors. These are the factors. The zeros are what makes those, if you set each of these equal to 0, that's a 0. So you set those equal to 0, and that's a 0. The x-intercept is actual physical location, the point. To determine the graph of this thing, we know we have the intercepts there. So what happens at the end behavior at those only 2 points? What happens to the graph at that point? So we look at the leading term. A is 1. It's a positive 1. N is 2. It's even. So what happens if A is positive and N is even? If A is positive and N is even, the graph from the end points, they both go up. Yeah. But you don't have to shout. It's very quick and easy to write it down. The first term, this is called the leading term. The leading term is made up of a leading coefficient, which is the number in front of the x, and it's made up of the degree. So if a is positive and n is even, that means from the last points of the graph goes up. What happens in the middle, we don't know. If a is positive and n is odd, that means they both go different directions at the endpoints. So we know from there, the graph will look something like this. Now, since it's quadratic, we have to figure out more points. The next point, so we found the x-intercepts, we found the zeros, or all those things. We have to figure out what's the lowest point in this case. How do we know we have a lowest point in this graph? A minimum. Well, because of the leading term. We know that the graph at both ends points up. If they point up, that means there has to be a low point somewhere between there. That low point is called a vertex. The vertex is the high or low points of a graph. So this point here, that's the vertex. This point here, that's a vertex. That point there, that's a vertex. That's a vertex. So a vertex, what really defines a vertex? If you think about it, look what happens here. Since we know this is a vertex, how do we know that? Because on the left side, this is called a minimum. Because on the left side, is the slope increasing or decreasing? It's decreasing. So the slope here is negative. What happens on the right-hand side? The slope is increasing, so the slope is positive. So if the slope is negative on one side going down, positive going up, it's got to change somewhere. At this point here, the slope is equal to 0. The point where the slope equals 0 is the vertex. Do all functions have vertices? That's plural. No, linear equations don't. Rational functions don't. What are rational functions? This is y equals 1 over x. This is y equals 1 over x squared. There is no vertex anywhere there. There's no high point or no low point. It keeps on going forever. And it never stops. So there are no vertices in this case. So, but pretty much most of the other ones have vertices. If they're continuous functions. Are these continuous functions? No, because if I start drawing this graph, can I keep on drawing it to the other side? No, so that's not continuous. There's a jump in there somewhere. Like this one here, since on this side, on the left-hand side of the vertex, we have the slope is positive, it's going up. And the slope going down, it's negative on the other side. Here it's 0. So this is a maximum. Think about it. On the left-hand side, if the airplane's going up and then starts going down, is it at the high point or is it the low point? If it's going up and then starts going down, is it at the highest or lowest point? It's the highest point, so that's a maximum. If it's negative, if it's going down, then starts going up, is it at the highest or lowest point? Lowest point. So that's, look at it that way. No. In this case, these are called absolute extrema. Because in the quadratic equations, you only have one low point or one high point. You can't have anything else higher or lower. But a cubic function, yeah, we have multiple of them. These are called relative extrema. Because it's relative to a small part of that picture. This is a maximum of this small part of the picture. This is a minimum of that small part of the picture. Here's a minimum, and here's a maximum. Is there an absolute max or absolute minimum there in this whole picture? No. Because is there any point bigger than this one? No, it keeps on going forever. Like there's no absolute, there's no one point that's higher than everybody else or lower than everybody else, like these guys. So they're relative maximum minimum.
What is the extreme?
Ah, good question. What is extrema? When I say the word extreme, what does it mean? It's the, like, if you think of what's that? Red Bull. They always sponsor extreme sports. These are the people, the athletes that take sports to its highest level. The highest level. That's what you're saying is when you talk about extrema, you're talking about the highest level or the lowest level. The highest athletes can go, or what's the lowest they can go? That's the extremes. Nothing is more difficult than those, or higher or lower than those. Yeah, that's a good question. Extrema is simply the Latin word for extreme. Plural of it. If it's singular, it's an extremum, but extrema means there's more than one. So, in quadratic equations, quadratic equations look like this, or quadratic functions. We know it's quadratic. Why? Because the degree is 2. Very good. Which means we only, since the degree is 2, that means we have 2 solutions at most. So we can either look like this, or we can either look like this. So we only have one extrema, the vertex. So to find the vertex of a quadratic equation, so to find the vertex of a quadratic equation, in the standard form, this is standard form right here. If it looks like this. Did we discuss the quadratic formula yet? I think we did in chapter 3. I hope we did.
Or, yeah.
I know you've seen it before, but where do we introduce it?
I remember seeing it before.
Yes, I mean, now was it in high school or yeah, but this is the quadratic formula. Only works for quadratic equations. But if we haven't discussed before, then we'll discuss it now. The quadratic formula, this is the quadratic formula. What does it do? Finds the x-intercepts or the solutions. So far, so good. Have we talked about completing the square? Does that sound familiar in chapter 3? Completing the square. No, because a lot of stuff just blends in together because it all goes together really well. So let's look at this way. So here's a quadratic formula. I'm starting at the end. We're going to work at the beginning towards the end. What this is going to tell us, the quadratic formula will tell us the solutions, the x-intercepts. Remember, there are 3 possibilities. We can either have 2 solutions. We can have 1 solution, or just touches the x-axis, or we can have no real solutions. We have 2 real solutions. We have 1 real solution, or we can have no real solutions. So this is what's going to happen here. Now notice how I put real solutions. If they're not real, what kind of equations are they? I know we talked about this. At least we did when I was gone. Imaginary. We talked about imaginaries, didn't we? So if they're not real solutions, then we're going to have I answers. What is I? When we say imaginary numbers, where does that come from? That comes from when you have a negative inside a square root. And here, we only have 1 solution, is if we have 0 inside the square root. And here is when we have a number that's bigger than 0, if it's positive. You notice how it related to that? That's this part here.
We talked about it. I don't know.
Yeah, I know, it's all gets jumbled up in the head. That's called a discriminant. Discriminant determinant. I think it's a determinant. Because we'll talk about discriminants, the other word, to find some more solutions later on. Determinant. The determinant part is the b squared minus 4ac. It's whatever's inside the square root. Let's think about it. If whatever's inside the square root is a positive number, like 4, can we take a square root of it? Square root of 4 is 2. So if that number is greater than 0, then we're going to have 2 solutions. Why 2 solutions? Because we have a plus or minus. I'll show you, we'll do an example about what this means in a second. If this determinant, if it equals 0, then that part disappears. All we have left is negative b over 2a. That means there's only one solution, and that's negative b over 2a. If it's negative, that means it's imaginary, then we have no solutions. No x-intercepts. Okay, let's look at some of these examples. And then we haven't finished factoring yet. So I'm just still taking this one step further. The example we had earlier, x squared plus 5x plus 6. Let's look at what do we know about this so far if we have to graph this? How many solutions are we going to have? At most 2. Very good. So we know, and what kind of graph is it going to look like? It's a it's parabolic. Yeah, it's a quadratic equations. It's a quadratic equation, so the graph is a parabola.
Can you speak parabolic? How do you say?
Yeah, it's parabolic in shape. It's a parabola. Parabolic, it's the shape is parabolic. It is a parabola. It sounds weird. A lot of times I say parabola because it helps me spell it too. It's parabolic in shape, which means it's a curve. Think about it. What does parabolic mean? It's like a satellite dish. Those are parabolic. So
Half.
yeah, just take a circle and cut it in half. It's parabolic. What else? By looking at this, what else can you tell me? Do we know any points on the graph? No, just no calculations. Just by looking at it, can you tell me any points? You can't tell me that by looking at it. I'm gonna give you one even more difficult. See if that works. Just by looking at it, the answer is yes. What does this number tell us? The y-intercept. The constant is always the y-intercept. So we know that there's a dot right there. That's all we know so far. We know the shape of it. We know it's a parabola. Is it opening up or is it opening down? Why?
Not negative?
Very good, because the leading coefficient is positive. Because A is positive, in this case, A is 1, that means it opens up. And we know that from that chart we had.
So there's no root,
No, we haven't got that far yet. Now we got to figure out the solutions. Because of this, we can factor it. If we factor it, we'll get x plus. We know they're both going to be the same. They're both going to be pluses. 3 and 2. What times what is 6? When you add them, you get 5. 3 and 2. So what are my x-intercepts? Right, so at -3 and -2. What else do we know? Parabolas, the squared functions. We know they're symmetric. Do we know any other more points? Yeah. If we go to this point and 2 to the right, up 6, we got a point. So this one here, if we go 2 to the left and up 6, we'll have another point. Because it has to be symmetric. What's the axis of symmetry? Did you hear that word? Axis of symmetry. The axis of symmetry is the x value of the vertex. Because, again, a quadratic equation, it's symmetric. There has to be a number where I could fold it so it's equal both sides. Yeah, so it should be -2.5 or -2.5. But how do we find that mathematically? So remember, it's the x value of the vertex. The vertex is a location. The vertex is a location. Remember the quadratic formula. The x value of this equation is simply the -b over 2a part. So get rid of this part. That is the axis of symmetry. So what is A, what is B, and what is C in our equation? B, yeah, A, B, and C have to be numbers, no letters. So let's look at this. Let's plug these values into this equation. So we have B is 5, A is 1. So we have -5 over 2 is -2.5. So that's the axis of symmetry, is the x value of the vertex. What does that tell us? It tells us somewhere on that line, the vertex has to sit. Well, we know it opens up because of, that means the vertex has to be somewhere below there. Well, let's find it. How do we find the y value? Well, we know the x value. Plug it in, plug into our equation. So y is equal to -2. No, I'm gonna do 5/2 squared plus 5 -5/2 plus 6. If you're using calculators, yeah, you can put it -2.5 square and do all that sort of stuff, but you don't really need to. If you don't have a calculator, you can still do the work. So -5/2 squared. -5 squared is what? I square both of these numbers. So -5 times -5 is? I heard 25. 2 squared is 4. Next one is positive times negative is negative. Can anything cancel in this one? Top and bottom? No. Before, the rule is, before you, I think your door's locked. Before you multiply two fractions, thank you. Before you multiply two fractions, always reduce first, if you can. Since nothing cancels, 5 times 5 is 25. 1 times 2 is 2. Plus 6 over 1. To add these, we have to get a common denominator. So the smallest number that 4, 2, and 1 all fit into is what? 4. The smallest number that 2 fits into is 4. 4 fits. So 4 is our common denominator. That one's already 4, so leave the top alone. What times 2 is 4? 2. So we have to multiply the top. 25 times 2 is 50. What times 1 is 4? So multiply on top. So 6 times 4 is 24. They're all 4s. So we just worry about the top. 25 minus 50 plus 24. Mm-hmm. 49 over 4? No. Let's try. Let's combine like terms first. Since either are both positives, 25 plus 24 is 49 minus 50 over 4. 49 minus 50, they're both the opposite signs. 50 is bigger, so the answer is negative. 50 minus 49 is 1. You were close. So that's the y value of my vertex. -1/4. So my vertex is at -5/2, -1/4. Which quadrant are we in? They're both negative. Third one, yeah. Because we go to the left and then we'll go down. So we're in the third quadrant. And that's exactly what we're gonna say. So this value here is -1/4. Is it a maximum or a minimum? It's a minimum. Absolute or relative? Or both? It's absolute for sure, but absolutes can be relative also. So it's absolute and relative to this graph. Minimum. Let's do another example. What's that?
So that, um,
What do you mean, the absolute relative?
the relative, yeah.
Let's say I'm gonna start off with these points here. This is a vertex, right? Is it, first off, it's relative because relative simply means I can take a smaller domain and look at it. That's relative. Here's a minimum. I look at this domain. Now I look at the whole thing. Is this the highest of the whole thing? So we know it's relative to begin with, but it's also, in this case, it's absolute. Absolutes can be relatives, but relatives cannot be absolutes all the time. Like this example. Is this a relative maxima? Yes, because it's only this part. Is it absolute? Is there any point higher than this? So it's relative and absolute.
So the other one, I guess,
These are all relatives.
okay.
So absolute is automatically a relative. But relatives are not necessarily absolutes. These are all relatives. But there are other ones over the entire picture. Relative simply means over a small domain. Well, I'll try to make this one the same on the bottom.
So, relative.
Yeah, so both of these, so there is no absolute. If you have more than one, then it's not absolute. They're all relative minimums. Absolute means it's one and only one, highest or lowest. So the quadratic formula. What's the purpose of the quadratic formula? What's the purpose of the quadratic formula?
On. Find the X. in the intercept?
Yep, very good. Because we took this equation here and factored it. We got x equals -3, and we got x equals -2 by factoring. Let's not factor it then. Let's use the quadratic formula. Let's take this equation, use the quadratic formula, and see what our answers become. Let me write that equation down again. So we have y equals x squared plus 5x plus 6 use the quadratic formula to find the x-intercepts. The quadratic formula is -b plus or minus b squared minus 4ac over 2a. So to use this, what do we have to do first? First off, you have to make sure that all the x's to one side. In other words, set it equal to 0. Why do we set it equal to 0? Because we're looking for the x-intercepts. To find the x-intercepts, y has to be 0. So we'll move everything over to one side. Move everything over to one side. Label A, B, and C. What is A?
1,
What's B?
5,
and C. Now we plug them into our equation. So negative, what's B is 5. Plus or minus. The reason it's plus or minus is because you can have two possible answers. Square root B squared 4 times A times C over 2A. The quadratic formula is just an easier way to factor things or to find the x-intercepts than it is to factoring, because not all equations are factorable. And we're going to do that one next. So let's work this one out. We have negative 5 plus or minus. What's 5 squared? 25. Minus 4 times 1 is 4. 4 times 6 is 24. 2 times 1 is 2. This is just following the order of operations inside the radical. 25 minus 24 is 1. What's the square root of 1? 1. So far, so good. All we did was the mechanics of it. Now, this is where this plus or minus comes into be important. So we have negative 5 plus 1 over 2, negative 5 minus 1 over 2. This plus minus says we have to take both signs, one the positive, one the negative. Negative 5 plus 1 is negative 4. Negative 4 divided by 2 is negative 2. Negative 5 minus 1 is negative 6 over 2. Negative 6 over 2 is negative 3. These are my x-intercepts. I know it's a touching moment. Now, let's look at how this is important. How about that one? Can you factor that one?
Hold on.
Well, you can. Yeah, you could. 4 times 1 is 4. 4 minus 1 is 3. So that was a bad example. How about this one?
No, I did not. You
Yeah, but I want to try to trick you, right? No, because what times what is 5? Then when you subtract them, you get 3. Only thing that equals 5 is 5 times 1. So this one's not factorable. But we can use the quadratic formula. A is 1, B is negative 3, and C is negative 5. Plug in the values. Oops, I forgot. That door always locks.
Um,
So since this equation cannot be factorable, is not factorable, or you don't wanna waste your time in factorizing it, so just plug it in there. So we label A, B, and C. So B negative, B is -3. -3 squared minus 4 times 1 times -5. Negative makes it a +3. -3 squared is +9. Negative times negative makes it a positive. 4 times 1 is 4. 4 times 5 is 20. Over 2. Nine plus 20 is 29. That's as far as I can go. But square root of 29 can't go any further. It's a prime number. So what are my x-intercepts? My x-intercepts are 3 plus square root of 29 over 2. And x equals 3 minus square root of 29 over 2. Those are my x-intercepts. Square root of 29 is a little bit bigger than 5 because square root of 25 is 5. Square root of 36 is 6. So it's between 5 and 6, 5.4, 5.5. So far, so good. Where's the vertex of this equation? Very good. Well, that's not the vertex. That's the axis of symmetry. Because the axis of the vertex is negative b over 2a. Then whatever we get there, plug it back in your equation. That gives you the y value. So there's our negative b over 2a. So our axis of symmetry is 3 over 2. Now we take this equation and plug it in that. So let's see what that would be. The vertex would equal, let me see, it's 3 over 2. Y equals x squared minus 3x minus 5. Three over 2 squared minus 3 over 2 minus 5. Three over 2 squared becomes what? Squared. So basically it means just square both top and bottom. 3 squared is what? Yeah, 3 squared over 2 squared. Nothing cancels in the second one. So we have 3 times 3 is 9. 1 times 2 is 2. Minus 5. Which is 5 over 1. The common denominator is going to be 4. So leave the first one alone. I got to multiply the second one by 2. So it's 18 over 4. And the last one by 4. Nine minus 18 minus 20 over 4. Nine minus 18 is -9. -9 minus 20 is -29 over 4. That's the y value. Again, this is the hardest part because it's the most mechanical. So we know our vertex is at -29 over 4. That's the lowest point. Make more sense a little bit? Now there comes a problem. Because we've practiced factoring already, but everything we've practiced so far always had a equals to 1. What if a does not equal 1? Put it together here. Okay, what if we had this equation? What if we had that equation and we asked you to factor it out? Most of the stuff we talked about will work if it's factorable. Since we don't have a 1 here anymore, and we're solving for x, put 6x into both of these. What that does for us, we'll fix it at the end. So whatever the first number is, will go into both those spaces with whatever this is in the middle. The signs are the same. If the second sign is a minus, what does that tell us? They're opposite signs, and the bigger number gets the minus. So far, so good. We do the same thing we did last time. Take A times C, which is 6 times 15, which is 90. Take A and C, multiply them together. Now we got to figure out what two numbers multiply to give you 90. When you subtract them, it equals 1. B. Can we think of any numbers?
But that's what you're not even, you're not suspecting.
You get 1. 10 and 9. 10 times 9 is 90. 10 minus 9 is 1. Since the first sign is a minus, the bigger number gets the minus. So far, so good. Not much has changed. The only thing we really changed is we put the first number in front. Here's where it becomes different. At this stage, factor what you can out of both of those parentheses. What do 6 and 9 both have in common? They both have a 3 in common. So if I factor out a 3, what do I have left? The easiest way to do this, divide both of these by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. How about the next one? What do 6 and 10 have in common? 2. So I divide both of these numbers by 2. 6 divided by 2 is 3. X. 10 divided by 2 is 5. Oh, so far so good? Once I have those, I factor out both of those. Whatever I factor out, erase. Because those are what was common in both those to begin with. We don't need those anymore. These are your factors. So this equation factors down to 2x plus 3, 3x minus 5. So my x-intercepts are where? What are my zeros? I'll show you a shortcut first, but yeah, then we have to solve it. I'll show you how it's going to work. Again, always take the opposite sign of what's there. If there's a number in front of x, it goes on the bottom. So the opposite of this one, which is positive 5, there's a number in front of x, it goes on the bottom. Those are my x-intercept, my zeros. Let's see how that works. 2x plus 3 equals 0. Subtract 3 from both sides. And divide by 2. Sure enough, it works. But you can use whatever method you want to. So far, so good. So it's not much big difference if if A isn't 1 anymore. It's just one extra step. What about if I gave you this? What if I gave you that? Can we use anything we learned so far into this one? The answer is yes, we can. But we have to first determine something. Is this quadratic? Not quite. Well, remember, what is a quadratic equation? Yeah. The degree has to be 2. This one's 4. But it is quadratic in form. Let's look at what quadratic in form means. To be quadratic, this is it, right? The middle term, what is the power of x there? 1. So if I have whatever middle, I have 3 terms, whatever the power of the middle term, if I multiply it by 2, do I get the first power? That's quadratic in form. This one, if I multiply it by 2, do I get 4? Yes. So because it's quadratic in form, I can use what we've done in the past. I can use quadratic equation. If I use the quadratic formula to solve it, remember, you're solving for this middle term. So what you would have is x squared equals negative b plus or minus b squared 4ac over 2a. If you're using the quadratic formula, remember, you always solve for the middle term. So you're solving for x squared. Let's go ahead and solve it this way first, then we'll solve by factoring. So what are A, B, and C? What's A?
1.
B, and C? Very good. Very good. How many answers are we supposed to have here? At most 4. So we have negative 2 plus or minus 2 squared, 4 times 1 times negative 15 over 2 times 1. Just plug A, B, and C inside there. We have negative 2. 2 squared is 4. Negative times negative makes it a positive. 4 times 15 is? Very good. 60. Negative 2 plus or minus 60 plus 4 is 64. Negative 2. What's the square root of 64? Very good. Can we do anything else? No. Well, okay, you're gonna do what? You're right. We're gonna do both sides now. So remember, what do they equal? They equal x squared. X squared equals negative 2 plus 8 over 2. X squared equals, bless you, negative 2 minus 8 over 2. So we can't forget that we're equaling x squared. It's the middle variable we're solving for. Negative 2 plus 8 is? The opposite signs, so 8 is bigger, so its answer is positive. 8 minus 2 is 6. 6 divided by 2 is 3. Negative 2 minus 8 is negative 10. Negative 10 over 2 is negative 5. We're not solved yet. We're not finished yet because we haven't solved for x. How do we get the x's by itself? We have to get rid of the square. So we have to square root both sides. The square root and the square cancel. Whenever we square root something that's squared, we have to put a plus or minus in front of the answer. So x is equal to positive square root of 3. X is equal to negative square root of 3. Same thing on this side. Square root both sides. So x is equal to plus or minus square root of -5. What's the problem with that one? It's got a negative inside there. How do we fix that? Very good. It's imaginary. Which is when you said earlier, at most we'll have four solutions, four real solutions. We have two real solutions and two imaginary solutions. So our x-intercepts are radical 3, negative radical 3, I radical 5, negative I radical 5. Those are my four answers. But these aren't really intercepts. So if it's quadratic in form, this is how you'd solve it. Using the quadratic formula. Did we have to use the quadratic formula? Let's look at the same example. This time, let's try factoring. So what goes in first? What are we solving for? Remember, always look at the middle term. X squared, x squared. Well, first off, is it quadratic in form? Yeah, before you do anything, make sure it's quadratic in form. Because if this was 2 and this was a 5, you can't do what we're about to do. It has to be quadratic in form first. So since we're solving for x squared, that goes first. They go first for us. Second sign's a minus, so they're opposite signs. The first sign is plus, so the bigger number goes there. So 1 times 15 equals 15. What times what equals 15? When we subtract them, it equals 2. What two numbers multiply give you 15? 5 and 3. 5 minus 3? Yes, that is the hardest part of this whole process. Because you have to go through all the different combinations of numbers. So, since the plus is the first sign in my equation, the bigger number, 5, goes in there. So far, so good. Now I take both of these and set them equal to 0. We got to solve for x. So in the first one, we have to subtract by 5 from both sides. And the second one, we add 2 to both sides. Square root. So x is equal to plus or minus square root of -5. Square root. X is equal to plus or minus square root of 2. Where did I get 2 from? None of my answers are right now. It should be a 3. This one's imaginary. So it's plus or minus I radical 5 plus or minus radical 3. And those are my four solutions. Positive I radical 5, negative I radical 5, radical 3, negative radical 3. Those are my solutions, which is the same thing I got last time. What do y'all think? The faster way is using quadratic formula, really, because this way it works great. Because what if it wasn't factorable? You would spend so much of your time trying to make this thing work that time. This way, the quadratic formula method will always work. It's doing everything for you. If this was a 3 and that was a 15, would that work? No. What times what is 15 when you subtract and you get 3? Nothing. But you would spend so much time trying to make it fit. It's again, if it's easy, if you can see it, this way it's faster, yes. But if you don't see it instantly, then use quadratic formula. They'll both give you, yes, you're right. In this case, it's a lot shorter, a lot easier, a lot straight to the point. Which shows us now about graphing. So this is where we need to find the x-intercepts. The x-intercepts, how do we find the y-intercepts?
She said the last time.
No. How do you find the y-intercept? You're thinking way too hard on this one.
Minus b. No, it's not. Over 2. No, that one's very close.
Yeah. It's always the constant. Yeah, set x equal to 0. Whatever you end up with is your y-intercept. Yes, you guys are overthinking it. It's the x-intercept, set y equal to 0. The y-intercept, set x equals 0. Now, why is that important? If it's in standard form, it's super easy. It's always the constant. We have another form of these things. The equation can be written in vertex form. That's vertex form. Why is this called the vertex form? Because the vertex is HK. When have we seen that before? HK? Very good. It's the equation of circles. Here, I'm going to ask you two questions. Tell me the vertex. Tell me the y-intercept. Well, I'll ask you three things. Okay, I'll ask you three things. One, tell me the vertex. Tell me the x-intercepts. And then tell me the y-intercept. Very good. It's always the opposite, the inside of the parentheses, and it is what it is. The vertex is 3, 2. Very good. Y equals. So the vertex is at 3, 2. Two. The x-intercepts. How do you find the x-intercepts? Set y equals 0, solve for x. Set y equal to 0. And find the x-intercept. So how do we solve this one? Solving for x. Get rid of the 2 first. Subtract 2 both sides. So we have -2 equals x minus 3 squared. Then what? I'm trying to solve for x. To solve for x, what do I have to get rid of? The square. How do you get rid of the square? Square root both sides. And because it's squared here, I have to put a plus or minus on the other side. Plus or minus square root of -2 equals x minus 3. Add 3 to both sides. So x is equal to 3 plus or minus square root of -2. Ruh-roh, what's wrong? It's -2, which tells us that we have an imaginary number. So do we have any x-intercepts? No. We know the vertex is at 3, 2. There are no x-intercepts. Do we have a y-intercept? How do we find the y-intercept? Look, we find the x-intercept, we got rid of the y's, right? Get rid of the x, so set x equals 0. 0 minus 3 squared. 0 minus 3 is -3 squared. -3 squared is +9. Plus 2 is 11. So the y-intercept is at 0, 11. Right, it's at 11. Which we kind of knew that we weren't going to have any x-intercepts. How do we know that? How do we know we're not going to have any x-intercepts? Let's look at the graph. We know the vertex was at 3, 2. Yeah, it's well, because the vertex is above the x-axis. And what's A? What's A? A is positive. A is 1. So it opens up. we can look at it so that we know we're not gonna have any x-intercepts. But we do know that we're gonna cross the y-axis at 11. At some point. Yes, at 11. Which we can draw this even better. We're at 3, 2 here. So if we go 3 up 11, we're at that point. That means we go 3 more here, up 11, we have another point. So our graph is going to look something like this. Because of symmetry. Thinking, do we want to look at, because these are just the quadratics. If you're graphing polynomial equations, because in quadratics, we were pretty lucky in that we now have a method of factoring out the equations. We have a couple of methods, actually. But a polynomial equation, what if I gave you okay. As of right now, we can't do anything with it. Because we haven't learned any methods on how to fix that. That's what the end of this chapter is about, chapter 4. And this is actually not, this is pretty small. We will be able to take any equations of any size and be able to find the x-intercepts, the y-intercepts, and graph them. So what I have to do first is, in this case, I would give you the factors. How do I know we're supposed to have 3? Okay, this is not legitimate. I just made these numbers up. So don't go. We're going to learn, we're going to go from here, we're going to factor them. How do we know I'm supposed to have 3 factors? Because my degree is 3. You're right. I have 3 x's, x cubed, 1, 2, 3. All this stuff all fits together now, so you know to look at. My y-intercept is 1. I know that by looking at it. It's a cubic equation. What is that graph going to look like? Exactly. It's either going to look like this or like this. The end behavior has to be different because n is odd. Since a, the coefficient, is positive, it has to go like this. When I factor it, what I'm looking for are my x-intercepts. In this case, what are my x-intercepts? Very good. -2, +3, +1. What's my y-intercept? Yeah, it's at 1. We know that it's a cubic equation. It's increasing. So the end behavior, so the end points have to look like this. The question is, what happens between those now? Well, because we know this y-intercept here, this thing has to go over something like this. And then this side over here like this. That's what we're looking at here. For any size polynomial, that's what we'll look at. I really can't. Because, well, we can find the vertices. But remember, it's at the points where the slope is equal to 0. So we have to find the slope equations for all of these points, which is a lot of extra point work. Right now, we're just trying to get the sketch of the graph what it looks like. And we'll build those points later on. Roughly sketch this graph. To sketch this, what kind of equation is this? What's the degree? What is it? No. Exactly. The degree is, I'm glad you said that, because you know how we had x to the 5th says it's a 5th degree, which means that there's 5 x's. I'm glad you caught that, because there are 4 x's, the degree is 4. So it's a 4th degree polynomial. What does that graph look like? Right, it looks something like that, because we know because it's even, both ends point the same direction. Does it point up or down? Why?
Positive.
Well, because all the x's are positive. Yeah, so it's gonna look something like that. We'll have at most 4 solutions. Where are my solutions at? Only 3.
Positive. -1. Would it be 1? No.
How did you get 2 as this one? Yes, but mathematically, how do we do it? Right. How'd you do this one? How'd you do this one? How about this one? Very good. Yeah, the same logic is, there's a lot, like, to be honest with you, a lot of people forget about that x in by itself, but it is very important aspect of it. So we know the x-intercepts. Do we know the y-intercept? Can we find the y-intercept? We can always find the y-intercept. What's the procedure to find the y-intercept? Set x equal to 0. If you set x equal to 0, that's a +1, -5, +2, and 0. So the y-intercept is 0 times 2 times -5 times 1
It's 0.
is 0. Because anything times 0 is 0. So yeah, so it's because so now we know what the graph looks like, kind of, sort of. What do we know about the end behavior? The degree is 4. Yep, they go the same direction, up or down? Up. So the reason they call end behavior, because the end points, from those points, the graph goes up. In this case. Now we got to figure out what happens between there. Because there are a couple of things that can happen. Will the graph go below the x-axis and then back up and then like this? Or will it bounce? How do we know it's going to bounce? All that tells us is that they both go the same direction. Well, let's look at the easiest way to do this. Let's look at, so if you're saying it's going to bounce, we know the y-intercept at 0. That works there. What happens if we put x equals 1 in the equation? If we put x equals 1 in there, is it going to be positive or negative? Well, let's see. If we put in 1, so that's positive 1, 1 plus 2, 1 minus 5, 1 plus 1. In place of x, I put a 1. 1 plus 2 is 3. 1 minus 5 is negative 4. Positive times negative times positive is a negative 24. The answer is negative 24. So at this one's going to be way down there. So it doesn't bounce. What's going to happen here is this. It'll have this basic shape. No bounces. No, how do we know? I'll show you. I'm glad you brought that up about bouncing and everything like that. I'll show you how we know if it has a bounce. What does that graph look like? It's a parabola. So the parabola looks like this. But the degree is 2. How do we know? Why doesn't it go below there? What's my x-intercept? Yeah, if I set y equals 0, x equals 0, so that's the only point we have. So the x-intercept at that point, it bounces. It doesn't cross through. It bounces. Why? Because the exponent of that value is even.
So for it to bounce on the last one, every x had to be 0.
All the exponents had to be squared. See, all of these exponents, this is a 1, this is a 1, this is a 1, and that's a 1. So if any of these had had 2, at those points, it would bounce. We call these the multiplicity. The multiplicity is how many times does that number multiply to itself? Since all of these are odd, if odd, then cross. In other words, at that 0, since it only has a power 1, we know it crosses. At negative 2, its multiplicity is 1, so it crosses. At negative 1. So also, if you look at the sum of all multiplicities equals the degree. 1 plus 1 plus 1 plus 1 is 4. So what this is saying, let's sketch this graph. Because now we're putting a lot of this stuff we talked about today together. What's my degree? And what is A? Is A positive or negative?
Positive.
Why? Very good, because none of the x's are negative. So A is positive. What's my degree?
One.
Remember, I just said it is 7. Because the degree, where's that? The sum of all your multiplicities is your degree. The multiplicity is simply another way of saying exponent. 1 plus 2 plus 3 plus 1 equals 7. So we know the degree is 7. It's odd, and A is positive. What do we know about the end behavior there?
Even, so we're gonna go.
Not even, it's odd. 7.
I mean,
If it's even, they go the same direction. If it's odd, they go opposite direction. And since A is positive, it goes up there and down there. So this tells us opposite directions. That when you first came in, you asked me for that chart you took a picture of. So this is what happens at the end points of our intercepts. So what are my intercepts? What are my intercepts? And the first one is 0. Positive 2. So those are my x-intercepts. My end behavior says from the endpoints, this one's going to end up going up. This one's going to end up going down. Now, we have to ask ourselves, is it at these intercepts, do they cross or do they bounce? At -2, what happens?
Can it be some of them down and some of them
Yes,
up?
they can all be bounced. They can be, but it all depends on what?
On the degree.
The multiplicity. So at -2, its multiplicity is 2. What happens there? It bounces, so it comes back down. At 0, it crosses. At +2, what's the degree? Is 1, so it crosses. And at 3, it crosses again because it's an odd. It only bounces on the evens and crosses on the odds. So that's what the graph is roughly going to look like.
Wait, the only process with odds.
Cross odd multiplicities, bounce even. Yeah. What do y'all think?
Not
me-
that I think it's easier.
Let me give you another one here. And yeah, because remember, these are the easy ones, because I'm giving you the factor of it. The next part we're gonna do next week is we're gonna start learning how to factor these polynomials. And there are a whole bunch of rules that we have to follow there. But then once we finish that, the course is pretty much downhill from there. But everything after that is much easier. I ran out of space, so I had to stop. Sketch this one. All right, let's begin this. What are my intercepts? What's the first one?
+3, -1, +4, +1, -3.
So this is 3, -1, 4, 1, -3, right? That's the first thing you have to do, sketch it. What about the end behavior? What's the degree of this polynomial?
It was,
Very good. Since the degree is 16 and all the x's are positive, a is positive, what's the end behavior going to tell us? Very good. At both ends, they both go the same direction. Since a is positive, they go up. At -3, what happens?
down.
Yeah, -3, since it's an even exponent, it bounces. What happens at -1? Then at +1,
Across
it crosses it because it's an odd exponent.
Here's why I'm confused. I don't know. I mean, for me, I know it's gonna down, but how does that work?
Yeah, it bounces. And at 4, it also bounces.
Oh, did I?
Bounces off, exponent.
Yep. Yeah, once you look at it that way,
I was just gonna go like draw a line. Like in the middle. Like this.
no, no. It just, it just bounces off there. Exactly the same thing this one did. It's just that these two are close together. And because of what was going through your heads, you're wondering how this happened. That's what you always want to make sure you keep on questioning. Is this correct? Is it possible? So we know that at this one, it's even, so it has to bounce. At this one, it's even, so it has to bounce. Once you start putting all this stuff together, that's what the graph is going to look like.
See, that's how it happened. It's like between the points, but nothing in the middle, because I know what to do.
It's just
So,
everything else goes in there. Well, let's look at, let me look at something here. there's a program we use sometimes called Desmos.
Oh, yeah, I used to live in high school.
Yeah, it's interesting because it gives us the graph of a function. So here's I'm gonna say y equals x minus 3 squared button squared times x plus 1 I don't want square, I want something better. This one's going to be 5. Oops, wrong down. So x minus 4 squared x minus 1 to the third and then x plus 3 to the fourth. This is what the graph will look like. But you notice how it came down here, bounced up, crosses, crosses, bounce, bounce. Yeah, makes it easier if yeah, put just dumb numbers in there. But we have the right graph. We know that's what's supposed to happen because if you look at the x-intercept, there's nothing down here. There's nothing down here, which is exactly the same as what ours look like. There's nothing down here. There's nothing down here, just in the middle. Last question. What would the y-intercept be?
The maximum values, right?
The y-intercept?
Oh, I mean, no, right.
It would be absolute minimum, but what would the value be? Yes. And let's look what happens there. If we put all the x's to 0, then we'd have negative 3 squared, 1 to the 5th, negative 4 squared, negative 1 cubed, 3 to the 4th. All the x's disappear. So negative 3 squared is 9. 1 to the 5th is 1. Negative 4 squared is 16. Negative 1 cubed is negative 1. And 3 to the power 4th is 81.
Minus 1. Power of 5 1.
1 times 1 times 1
Oh.
times 1.
Right.
So the answer is going to be negative. There's only one negative. Negative 9 times 16 times 81. So you see how far down it's going to get. Some weird numbers, yeah. Again, that matches what our picture says. Our intercept is going to be down here in the negative someplace. Some huge negative number. So that's how we use polynomials. How do we sketch the graphs? Really quick, let me just work backwards a little bit. So if I gave you, if my x-intercepts were x equals 3 and negative 2, what would the polynomial look like? What is the polynomial of that function? we have to work backwards here. I gave you the answers. You have to give me the question pretty much. So let's work backwards. If I gave you this and I asked you to find me the intercepts, what would you do first? You'd factor. So you get x plus plus. What times what is 6? Adam it's 3 and 2. So x is equal to -3 and x is equal to -2. So what we did here, we took x plus 3, set it equal to 0, x plus 2, set it equal to 0. So far, so good? We're going to work backwards now. If I give you the answers, I say x equals 3, x equals -2. Set them equal to 0 first. Then take both of these and multiply them together. So it's x minus 3 times x plus 2 equals 0. Multiply these together. X times x is x squared plus 2x minus 3x minus 6. There's your polynomial. If I give you the answers, work your way backwards. I mean, and then it also doesn't matter how many of those I give you. X-intercepts were 0, -2, and 5. What is the polynomial? What's my degree of that equation? The degree tells us what? The degree tells us the number of solutions. How many solutions do we have? So we know that our polynomial has to be degree 3. The degree is the number of solutions, so it has to be 3. How do we get those? Well, take each of our solutions. These are my x-intercepts. This one's as far as it can go. This one and this one can be worked out further. Take all my x's, the equations, put them together, set them equal to 0. Now multiply. X times x is x squared, -5x, and -10. -5 plus 2 is -3x minus 10. And distribute one last time. You get x cubed, 3x squared minus 10x equals 0. So this is my polynomial. This is how you work backwards. If I give you the answers, you can tell me where it came from. Just by setting each one of them equal to 0, then taking all those and multiplying them together. This is where we'll begin next time. I know. It's a lot of stuff to cover, but we're almost done because once we get done with chapter